So a couple more examples of fancy they're not that fancy, but trigonometric integrals. So can you guys help me with this first one? Is it a peel problem or using another identity problem? Using another identity problem. And there's a couple other identity problems in your assignment that you're going to have to go to a couple other identities in your book. I don't think they're super clever though. All right, so how should I write this then? Cosine squared of 5x twice. That's sounding like peeling. I think you want to think of it as cosine squared squared. I mean, you can do it that way, but I think that's going to be extra work. It's up to you. That'd be fine too, but it's sounding like peeling if you do it that way, you know what I mean? So cosine squared, we had an identity substitution for that, so hopefully you have it memorized by now. What is it? 1 plus cosine of 2
times that thing.
Times what, Brendan?
5x.
Times that stuff, right? This is what gets doubled. So it should be 2 times 5, which is 10x. That's the part that can be tricky, right? And then over 2, and it's plus for sure, because the other one's exactly the same. Sine squared, you do the same thing, except it's minus, right? And now we have this whole thing squared, so we say, all right, that's going to be equal to 1/4. If I pull the 2 on the bottom out and square this guy, so that's 1 plus 2 cosine of 10x. You guys follow me? Anna, you okay? Plus cosine squared of 10x. So then that's going to be 1/4 times 1 plus 2 cosine of 10x plus, what am I going to do with that? Same thing, exactly. Plus 1 plus the cosine of something over 2, but what is that something? 20x. It's 20x because we got to double that angle. And so we're going to have, let's simplify a little bit, 1/4 integral of 1/2 plus 1 is 1.5 plus 2 cosine of 10x plus 1/2 cosine of 20x. Now I think we can finally integrate each of those little pieces. Let's do it up here. So final answer should be, what's a quarter? Oh, that's right, this is a fraction. Come on, I should know we should do that in calculus. That's going to be 3/8 x. And you guys help me with this one. We have 1/2, right? Chain rule, that's going to be 1/20th. Is it going to be a positive or negative, though, if we integrate cosine?
Positive.
Positive. Kyle's on it today. Cosine of 10x. You guys agree? Okay, be sure.
Sine.
Oh, yeah. Yes. Good. And this guy's going to go like the same way, right? We've got 1/8. We're going to have to compensate for that 20. So 8 times 20 is 160. Is that right? So plus again, right? And sine, of course. There we go.
Shouldn't it be 5 sine of 10x? Or I mean 1/5 sine of 10x?
Here?
Yeah, 1/5 sine of 10x.
Well, we've got 1/4 times 2 is 1/2. And then we've got to compensate for this with this chain rule, so it's going to be 1/2 times 1/10 is 1/20th. So I think we're good there. Are we okay?
Yeah.
So of course you can do like one more step and make that a little easier. I don't know. I hate writing it down lots of times. I don't have so many markers these days. Markers aren't liking me, so yeah. Okay, let's look at this other one. And you guys can work on yours. Okay, should we do this one with peeling, or should we do it like we just did, something like what we just did? Yeah, tangent and secant very often works like that, so I think it'll work this time, won't it? We could change it all into secant squared terms, or we can change it all into tangent squared terms. I'm not sure what's going to work. Let's just try one, shall we? We have to back up. We have to back up. It's okay. So let's leave a tangent out. Yeah, I think that's something we definitely want to do. So then this would be what?
1 minus secant squared.
Is it 1 minus secant squared? Be careful.
Oh, it's tangent.
So let's go to the identity.
Oh.
Okay, so if we do that, then u could be this. I don't know. Oh, and we've got 3 x's too, right? Oh, sorry, thank you. That's true. That shouldn't make much of a difference, so I don't think. I don't think that was the best way to go. Oh, maybe it is. Maybe we should turn this one into tangent too. Let's see what happens. I don't know. I'm just going to try it. So then this guy could be tangent squared squared, right? And tangent squared is secant squared minus 1. Right? Squared. Then we've got secant squared minus 1 here too. Well, that's good. Those are the same thing. That's more promising. So that's really just secant squared 3x minus 1 cubed. But see, now if u is secant, then that's not du, right? So maybe we should like reverse this process. I'm not sure. Any ideas, guys? You just have to play around with combinations of it. It's going to work. The thing is, no matter what do we have to have outside if our approach is going to work? If we're going to make u tangent, then what do we have to have lurking outside? Secant squared. So can we get that somehow? We could like back up to here, right? Like, don't we have a secant to the 4th right there? So maybe we should just leave one of those outside, you know what I'm saying? And make the other one do this kind of thing. So let's back up a little bit to right there. And we'll leave one of them right here for u substitution success. And then we'll have another one, right? And then we'll have this one still. So maybe instead of going like this, maybe we should have just left that as tangent cubed. You know what I'm saying? Let's go back up there and change it back. So really this is just tangent cubed right here, right? I mean, this is the decision-making process you guys are going to have to go through, so I'm kind of glad we messed up a little bit. It's not always going to come out nice when you're working on it. So now I need to do one more thing. I can make u here and be u cubed, right? Of course, we've really got like another u substitution inside, but it's just a 3x. We're not going to do that. So I need to do what with this one? Make it tangent, yeah. So we'll go up there and say this is tangent squared. Well, I'm just going to write it out in the next step. So this is going to be secant squared of 3x times tangent squared of 3x plus 1 times tangent cubed of 3x. And now we can do a u substitution, I think. So no, just mess around until we had the right thing. The key, I think, there was thinking about, well, if I want to make u, I've got to have a secant squared outside somewhere. And I just want secant squared. So tangent of 3x. So du is going to be
1/3, yeah.
Well, it's going to be 3 secant squared of 3x, right? So then we're going to have a 1/3, yeah. So this is going to be equal to, get rid of this one. So we're going to have equals the integral. We'll put our 1/3 right here. Okay. And there is du. So du. And we've got u squared plus 1 times u cubed, right? Did we miss anything? I mean, I have some notation missing. But I think we're good. So it's going to be 1/3 u to the 5th plus u cubed. You go. Now, one thing when we're doing integration in this chapter that I think you really want to keep in mind is it's not like Archimedes or Isaac Newton or Gottfried Leibniz like made these things come out this way. They just come out this way. Those people just discovered ways like we just discovered to make it work. That is the antiderivative of that. Is this the only way to find it? Probably not. But it's one of the ways to discover it. So don't forget, you're discovering stuff. You're discovering antiderivatives of functions as you go along. There's just so many different possibilities. See you next time.